Hello and welcome back to module number 2. I hope you had a good week at school, the first week of school, and things are lined up and everything is going well. So today in module number 2, we are going to do basically a review of descriptive statistics, and we will discuss what is descriptive statistics, what is the major platform we use in descriptive statistics, and we will look at that also from the perspective of open source R and what R can do with that regard. I would like to emphasize again, with regard to the book, I had several students ask about, is it requirement? Yes, it is requirement, but if you want to use the website that I created for the book, I will post it also on Canvas, so you will have ability to do that. And in this module, I'm not going to cover chapter 1 to chapter 4. Chapter 1 is introduction, chapter 2 is research design, chapter 3 is data types and method of collection. And chapter 4 is how to run R. I'm not going to discuss it in this module because I want to start try to make more sense out of statistics with regard to R. And so this is where my focus will be. I highly recommend that you will read those chapters just to have a better sense why is it important to understand. So let's start with descriptive statistics, and I'm sure that most of you already covered that subject in high school or in the introduction to statistics course that you took in the university. I'm going to be very brief. I'm not going to go into details about the essence of it, but I want you to take full comprehension, because descriptive statistics will come back and we will use descriptive statistics as we go along. Example, when we are doing regression analysis, we use descriptive statistics in order for us to understand what does it means. And even when we take a sample, we use descriptive statistics to have our facts right in order for us to conduct this type of analysis. So two things that we have to remember with regarding describing the data in descriptive statistics. One is the central tendency, and the second one is the variation, which means this is where everything lined up for us in order for us to do that. In central tendency, we are going to cover mean, median, mode. Comparison into variation, we are going to talk about range, interquartile range, variance, and standard deviation. Again, I hope those terms, you are familiar with those terms. I will try my best to just go over them in more common sense and try to apply that into R in the end of the module. So mean, medium, and mode. The medium is the median point, the mode is the most frequently observed value, and the mean is usually we have the formula that we calculate the sample mean, the sample size, and the observed value, and we divide that in order for us to understand what is entailed. So a simple example, the most common sense is the mean, and we have two sets here with one mean equal to 3, the other set is equal to 4. How did I came up with those results? I added all the observed values, in this case 1, 2, 3, 4, and 5, and divided by 5, which will be equal to 3. But when we have in the second set, we have different numbers, and when we add them up and divide it by the number of observation, we are getting 4. So in this case, the mean is equal 4. The median is the middle number, 50% above and 50% below. So the median is not affected by extreme values. How do we find the median? we usually apply the n plus 1 divided by 2, which means that it is not the value of the medium, but only the position of the medium in the ranked data. And I will talk about ranked data as I did last time. This is something that we need to be concerned when we are trying to analyze example questionnaire and not just any data set. So this is how we find medium. Mode is again the values that occur most often, and it does not affected by extreme values. So it can be either numerical value or categorical value, and there might not be a mode in that set. So you have to be sure that there is no, when you are trying to figure out, you have some understanding of that idea. So let's take a simple example. We have 5 houses on a hill by the beach. Each price stand for the price of in the market, and we add those price together. So in the mean, in order for us to calculate that, if we add all together, we divide it to 5 houses and we get the mean. The medium is the middle value of the ranked data, and the mode is the most frequent value because we added 2 houses in that value. So this is again a short summary of what we expected. But one of the questions that I often insist that you will understand, which measure of the location is the best. And so the mean is usually used unless extreme value exists. The medium is often used, but it is not sensitive to extreme value. So again, the medium house's price may be reported for a region less sensitive to extreme or less extreme or outliers that the data represent. The next one is quartiles. And quartiles, what we have, we divided the entire data set into 4 segments with equal number of value per segment. So we have quartile 1, which is the value of 25% of the observation, and they are smaller than 75% of the rest of the data set. Quartile 2 is the medium, which is 50% are smaller and 50% are larger, and only 25% of the observation are greater than the third quartile. This is how we operate in this case. So how do we find it? N plus 1 divided by 4. This is for the first quartile. Quartile number 2 is n plus 1 divided by 2. And quartile 3 is 3 multiplied by n plus 1 divided by 4. So n is the number of observed values. Had to find the first quartiles, and again, this is a simple example. 9 plus 1 is equal to 2.5, and so this is where we find the quartile. Okay, so second part in our discussion of descriptive statistics, and here we are going to talk about range, interquartile range, variance, standard deviation, and coefficient of variance. So the idea here is that we are measuring the information based on the spread of the data value. And that's where the visualization come into play in order for us to understand why it is so important. The range is the simple way to measure the spread of the data, and it is the difference between the larger number to the smallest observation. So in this case, x minus x the largest number minus the x the smallest number, in this case 14 minus 1 equal 13. So it doesn't tell us much, and so there is a lot of disadvantages of range. Why? Because it doesn't tell us more than we want to know about the data set. So in this case, Those two cases show you the limitation that the range provides. And the interquartile is the next step. So it can eliminate some extreme values using it. And so the idea here is that you eliminate some high and low value observation and calculate the range for the remaining value. So in this case, quartile 3 minus quartile 1 will give it to me. So in this case, minimum, maximum, quartile 1 and quartile 3, and by doing that, we have the ability to say where is the range in that set. Now we are entering the standard deviation framework. And in the standard deviation framework, we're talking about variance. Variance basically is the average of a square deviation of the value from the mean. So in this case, every single element in this formula is part of the score in order for us to calculate the variance. So in this case, when we take the variance and square root it, it will give us the standard deviation. And standard deviation will probably the most measurement of all times. We will use it all the time, from sample to distribution and so on and so on. So be aware that this is part of the equation that we need to remember how to use it. So it has the same unit as the original data, but it shows the variation about the mean. So example, let's take a simple example of standard deviation. We have a set of data. We have the number of observation. We have the mean, in this case, is equal 16. And so this is what we do. We will take each single value. We will minus the mean, square root, plus the next value, 12 minus 16, square root. And we will add them together, and we will divide it 8 minus 1. Why 8? 8 is the number of observation minus 1, and we will come up with 127 divided by 7. If we will not square root that, that will be the variance. If we will square root those numbers, it will give us the standard deviation. So the standard deviation in this case is 4.24, and it's around the mean. So where the small standard deviation and large standard deviation, where does it stand for, and how do we actually doing it? One of the things that we like to do is comparing standard deviation. We have 3 or 4 sets, and we try to measure to see where the standard deviation is bigger or smaller. In this case, I have 3 data sets, A, B, and C. The mean in all those data sets is equal, and it's equal to 15.5. But when we take the standard deviation, you see that the difference between them, those 3 data sets. In this case, the data B is the more concise, more concentrated in that case, and where the standard deviation is equal 0.96. So what is the advantages of variance and standard deviation? Is that each value in the data set is used to calculation, and the value far from the mean are giving extra weight because the deviation from the mean are squared. Okay. One of the things that we will start talking about is coefficient of variance. It is measurements of relative variance. It always is presented as a percentage. So it shows the variation relative to the mean. So it can be used to compare 2 or more sets of data measurement in different units. So one of the things that we like to do is stock market and stock A versus stock B, and we will do coefficient of variance in order for us to calculate which one is the best in that sense. So stock A is equal 10%, stock B is equal 5%. Both stocks have the same standard deviation, but stock B is less sensitive with regard to relative to its price. So those are the things that we are always try to do. Shape of the distribution is another part that we need to talk, and it describes how the data is distributed. So we are talking about the measurement of the shape. Is it systematic, or is it skewed to the left or the right? And so in this case, we are trying to figure out what is the medium, what is the mean, and where is the medium and the mean equal or bigger one of the other. We also entail the empirical rule. So if the data distribution is a bell shape, then we can calculate that 68% of all the value of the population or the sample has some value that we can encounter. The same rule can apply to 95% and 99.7%, and this is part of our equation when we are trying to apply empirical rule to the data distribution. Now I'm going to change gears, and I'm going to start talking about open source R and how the open source R uses or apply to descriptive statistics. So we have two types of machine learning or machine languages. We have the machine language itself, and we have assembly language. Those things are quite different with regard to what they do and how they operate with regard to statistics or calculation. We also have high-level languages, and in this case, it's more similar to the everyday language that we use when we speak to each other or we text to each other, which means that it has more open structure with regard to what the code consists of. So the idea here is that we have a language that is running through the machine that give us interpretation to the command that we are applying, and by doing that we have some ideas how to do that. Part of the high-level languages, we have Forman, Kubo, all of those are old school programming language, but they gave us some structure or some syntax that we still need to apply or to understand. So computer programmer, a collection of instructions. It tells us how to provide the interaction, how to set up the data set, how to interact with the hardware and the process of the data. We always have in this high-level language, we always have the object, which is in this syntax that we're going to learn in this class, is going to be data object. Example, time object, or paycheck object, or invoiced object, or anything that we can convert into data set in order for us to apply. So it is part of the procedure or organization of the data that we need to take into consideration when we apply the R code. So let us start with R. How do we store data? I will start with a simple example, and I will try to follow up on that and try to make more if it will make more sense. So in this case, wherever R encountered the object, it will replace it with the data saved inside. In this sense, the first line is the A, and in this case, I will give the A object some value. In this case, the A value will be 1. So if I will ask the R, what is the value of R? He will need to give me an answer that this is the value, 1. But in this case, I can add to it, example, +2. and he needs to follow up on that and add that 1 plus 2 is equal 3. So to create an object, you have to choose a name and to use the last symbol as follow by a minus sign. Good names versus bad names. And again, this is where we are going to start seeing things that make sense and things that are allowed to. So my underscore number 1, yes, it can be a good name, but we are trying to keep it short. So a good name will be a short name, and you can always see what you have done by the command ls. So it will show me what is the object that we have here, my class, my number, my name, the class, and so on. It will give me all the objects that I created in my R platform or environment. So what is a function in programming language? A function is a name selection of a program that performs specific task. So in this sense, a function is a type of procedure or routine that allowed us to operate. Some programming language makes a distinction between a function, which returns a value, and a procedure, which performs some operation but does not return a value. And this is something that we need to always consider. A function in R is basically a fundamental building block in R. So R comes within a lot of functions, and I will post a list of functions so you will have the idea how to do that. Example, mean or standard deviation is a function in R. Why? Because this is a programming statistical language, and so the mean becomes a function like any other programming language. So example, the mean of 1, 2, 3, and R will calculate for us the mean of it. The second example is about the functional function. So in this case, I can extend the function and I can add more functionality to it. And so in this case, as you can see, it will allow me to do more calculation about that. So the list of all functions in R, this is a short list. I want you to apply to it, check it out yourself, see what is it entail. And there's another list can be more useful. Again, those lists are very helpful. The data that you pass into the function is called the argument. So in this case, in the mean, in the example below, 1 to 6. So in this case, if we will calculate 1 to 6, the mean, it will equal 3.5. So in this case, the idea is that the R arguments can be raw data, an R object, or even the result from another R function. So it gives you the flexibility to have many interpretation of many assemble of the data into it. So how do you write your own sample? In this example, what is a sample? So in this example, I will set up what it is in example. So C, 1 to 6, a sample will be C, in this case 1 to 6, sample size will be 2, and replacement will be true. I will talk about those components later on when we will talk about sample. But in this case, I'm writing my own function which calls sample. And when I will run the sample, it will pursue the same procedure as I declare here in the code. And by doing that, it will be replacement as a true replacement, and it will conduct the analysis. This function are also a first class object, which means that they can treat much like any other R object. So R functions can pass as arguments to other functions. So the function can be nested, so you can define the function inside another function, and the return value of a function is the last expression in the function body to be evaluated. And that's a really important thing to say up front, especially that most of you already took the R programming where we talked about that. So every function in R has basically three parts: a name, a body, and a set of arguments. When you're going to create your own function, you need to replicate those parts and store that in R in order for it to operate. The syntax of the function in R is like name the arguments that were going to be the default values. So the formal arguments are the arguments inside the function. And all of it is part of how do you treat and how do you run. A function argument can also be misleading if you have default values. Another component of in the syntax of R with regard to operation is the vector, is a sequence of data element of the same type. So when we are talking about the same type, we are talking about components of the data. Example 2, 3, and 4. They are the same, and so they will be able to be called vectors. And the vectors also can have been transformed or to represent logical values. What is logical values? Is it the idea of true, false of those values. And so the vector can also contain strings, and I will talk more about strings in a second, but this is part of our terminology with regard to do that. So when you use logical vector for indexing, the position of the logical vector is true in return and doing that. We can always modify the vector, which means that we can modify it by assigning it operator that will provide the description of the multiplication or any other things that we like to do. We also can delete the vector out of our equation in order to do that. In list in R, a list is a generic vector that contains other objects. For example, in the example, n consists of numerical value, s consists of text, b consists of true or false, but x is a list that combines the n, the s, the b, and the 3, and all of them is part of what it will hold up. When you want to import data, we can have it in different ways. One is to write the code itself. The other one is the idea that we can import data using files, and you can insert new folder, or from the desktop you can take whatever file you embedded in order for you to apply that, in order for you to import the data. But I want you to learn also the syntax of the code itself, just to make the idea of import that. One of the things that in the past, when I started to use R and import the data from Excel, one of the biggest problems that R and Excel did not talk so well. So the idea that nowadays we have application or package that allowed us to do this operation or import the data from Excel more smoothly, but basically it's nowadays you can drag the data into R and it will not take any problems. Back to our statistic discussion. And in R, we have the mean, the median, the range, the variance, and the standard deviation and summary. So we can contain an object, and in this case f, and the s contain numerical value of 3, 2, 4, and 1. I have a mistake here, my mistake, sorry. And so in this case, I can say what is the range, and he will give me the range, and he will give me the set of that. Summary, it provides me, if we have a large set of data, it will give me a summary of the mean, medium, and standard deviation, and we will discuss the syntax of R language. Includes we discuss the function, vector, and how to import. So basically, what I want you to start practicing or to understand, let's see a simple example. I will try to make more sense in this example. I'll zoom into it. So 5 plus 20 plus 60. Well, when I will hit run, he will run and it will give me the result in the console. 80 minus 100 minus 85, he will give me the result. Same goes. With regard to the container, we are creating X object, and in this X object we have numerical values. So in this case, he will remember that. So now I can ask the R to remember what is the mean of X, what is the medium of X, what is the mode of X, what is the standard deviation of X, and in the end, what is the summary of X. So let's start. So in this case, I'm going to do run, and it will give me the mean, the medium, the variance, and he will say numeric, the standard deviation, and the summary. He will summarize for me all the things that we cover in class. Minimum, first quartile, medium, mean, third quartile, and maximum. So this is the idea of R with descriptive statistics. That was the introduction. I hope you enjoy it. I hope you have sense what it is entail. You will have an assignment using descriptive statistics. I hope it's understood. If you're not, please ask questions. Until next time, have fun.